Yes, you can put on the first slide. Good morning, good day, everyone. We are starting soon. The GEO Climate Policy and Finance Workshop, day 2 is starting. Please wait another couple of minutes for everyone to join. It's 3 p.m. now in Europe. We'll be starting the workshop very soon. In the meantime, I would like to introduce myself. My name is Sara Venturini. I'm the climate coordinator at the GEO Secretariat, and I will be your chair throughout this meeting. I will be supported by one expert moderator, Mark Dowell, that you'll meet shortly. But before going into the content, I would like to give you an overview of the workshop structure. Let me remind you that this workshop is designed as a 3-day event, with the first 2 days addressing how Earth observation can provide input to climate policy at the national level and at the global level, and a 3rd day focusing on how Earth observation can support climate finance, which is a slightly different topic. So yesterday we had 15 panelists and 150 participants engaging in discussions on how we can match the demand for data and information by countries to support climate action and the supply of these Earth observation data and products by the GEO community. So we heard results from the climate change working groups on the GEO mapping across the work program activities, and there is some evidence that climate adaptation is one of the main areas of expertise for GEO as a whole. And from the presentations as well, it emerged that GEO activities are working to provide a number of targeted and effective Earth observation-based tools and products to support decision-making at different scales. But there's also an open question that was raised by the representatives from the Ipcc Secretariat as to whether adaptation should be considered global instead of only local. It's a very good question. And in the next slide, you will see how this question fits well with today's agenda. So the focus of day 2 is on Earth observation for collective ambition on climate. And the program is again very packed. The presentations will be addressing 3 angles of the same question. In session 1, we're going to learn about the Earth observation needs and challenges with regard to the global stocktake process under the Paris Agreement with 3 keynote speakers. In session 2, we will get an overview of existing and upcoming capabilities to monitor greenhouse gas monitoring from space. And in session 3, we will present how GEO activities are effectively contributing or could contribute to the global assessment, both on mitigation and adaptation aspects under the global stocktake process. So all these sessions will include an open discussion with the panelists, and the event is about 3 hours in total. There will be hopefully a 10 minutes break around halfway through the meeting. And really what we want to achieve from today's discussion is that all the participants become more aware of the activities across the Earth observation community that have a potential to support climate ambition, and also that we can find some convergence on some key policy messages on the value of Earth observations and the contribution of GEO to the global stocktake. And this is done in view of COP26, but also for the whole process under the UNFCCC and the Paris Agreement in the years to come. So before we start, let me give you some instructions to participate actively in this meeting. So please indicate your full name and affiliation in your account here on Zoom, so that we can know who you are when you interact in the meeting. And to interact with us, with the panelists, you can post your questions in the Q&A box, and the speakers will respond in writing or during the open discussion at the end of the session. And as you see, the program is very, very dense, and I will have to be very strict with time management. And yesterday we managed to keep to the schedule, but we can do even better today, I hope. So speakers, again, try and do your best to stay within the time allocated to you, and don't be upset if I set off the alarm or I appear to warn you that your time is up. And also be aware that we are recording this event, and it will be posted on the GEO website together with all the presentations and the workshop report. And this will be shared with everyone after the event. Also, if you're active on social media, you can use the hashtag EO4Impact and follow the GEO Secretariat on Twitter, so we can have a Twitter chat around the workshop. And I would like to give a special shout out to Belize GEO on Twitter, who is our best comm supporter, and you should follow him as well. Also, today is Belize Independence Day, so it's a good reminder. Right, without further ado, I'd like to open session 1. We start with 3 very short keynote presentations on the Earth observation needs towards the global stocktake. So I'm introducing the first speaker to the session, Joanna Post, Program Management Officer at the UNFCCC Secretariat. Joanna is in charge of the research and systematic observation negotiations, and she's really our main liaison between the GEO and broader scientific community and the policymakers. And she's also leading the Secretariat's support for strengthening the engagement on ocean-related matters in the negotiations. So Joanna will tell us about the global stocktake and all we need to know about the process. Joanna, over to you.
Thank you, Sarah. Hello, everyone. Thanks very much to GEO for inviting me to give this very brief overview of the global stocktake process under the UNFCCC. Next slide, please. I'll start with, this is a representation of the Paris Agreement, if you like. The Paris Agreement, as everyone knows, was decided in 2015. It's the commitment by countries, a legal commitment by countries to reduce emissions, to adapt to climate change, to limit global temperatures to well below 2, well below 1.5, to enhance adaptive capacity, to look at low emissions development over time, to aim to net zero globally by 2050, and really a vision of the future that is not the one that we're currently on. Now, the Paris Agreement itself is designed so that countries commit to, or they provide their nationally determined contributions, their national adaptation plans, which explain exactly how they intend to meet the goals of the Paris Agreement. There's progress reports within that context to report back on progress in terms of mitigation, in terms of adaptation, in terms of finance or finance support received, technology and capacity building. And then what I'm talking about today is really what's called the ratchet mechanism of the Paris Agreement, the global stocktake, which will take stock of the implementation of the Paris Agreement every 5 years, with the clear intention that there'll be recommendations to parties to strengthen their ambition and for parties to strengthen that ambition moving forward every 5 years, and an intention that national measures will be moved in this direction to increase ambition. Next slide, please. The global stocktake. So what is the global stocktake exactly? Well, it's Article 14 of the Paris Agreement. It's the point at which parties take stock at the global level of the Paris Agreement implementation. The mandate from Paris states that the first global stocktake will take place in 2023, and then every 5 years following that. And then, as I said, the outcome will inform governments the need to update, to enhance their national measures, their national contributions, and how to enhance international cooperation for climate action moving forward. So that's the what. Then next slide, please. Now, the themes of the global stocktake are really matched to the goals of the Paris Agreement. The global stocktake will look at the aggregated information globally on mitigation in terms of the effect of the nationally determined contributions, in terms of the state of GHG emissions, the state of the temperature goal, and efforts by parties to reduce emissions. The adaptation will look at observed projected risks and where we are in terms of adaptation efforts. It would look at finance and other means of implementation and support to the Paris Agreement. And then there's a number of cross-cutting issues that the global stocktake will also look at, such as risks and risk resilience due to extreme events, something we call under the political process the loss and damage work. We'll look at equity and fairness and other cross-cutting measures. So the global stocktake will be addressed thematically across these 4 areas. Next slide, please. So the how is the global stocktake going to work? Well, the Paris Agreement set the stage in Article 14 in 3 very short paragraphs. The how was negotiated in Katowice 3 years ago. And that really, the Katowice climate package, and it's a decision 19 CMA1 as part of that package, explain the modalities around how the global stocktake will work. And that set the stage now for where we are. The global stocktake, if you like, is just about to start based off of those modalities. And there's 3 very clear stages. There's an information collection and preparation phase. There's a technical assessment phase. And then at the end of 2023, a high-level consideration of the outputs and then advice to governments moving forward. So we're now starting with phase 1, which is the information collection phase. The modalities from Katowice also say that there'll be guiding questions for each stage, which is really something to consider in terms of response when providing inputs into the global stocktake. The global stocktake is also a space, the information collection phase is also a space where everyone is, from the modality set in Katowice, there will be a number of inputs that are mandated, but there's also an open call for inputs from UN organizations, from non-party stakeholders, as well as parties, and the mandated inputs that some are organized by the Secretariat, some organized by constituted bodies under our process. So it's really a gathering of information on where we are according to the themes. For further information on this, there's actually what we strangely call under our process a non-paper, but it's actually is a document that provides an overview of all of this sort of modalities for this first stage that we're coming up to now, and that's available on the webpage, which is on the final slide of this presentation. Next slide, please. So this really is a timeline of where we are heading with the global stocktake, and it's a little bit complicated, but it explains the 3 phases that I've just explained. So we're now here in 2021. Guiding questions are identified in the non-paper I've just mentioned for the first phase, the information collection preparation phase. This will then be gathered together with synthesis reports by the Secretariat, by constituted bodies under our process, and feed into the next stage, which is what's called the technical assessment. And there will be 3 technical dialogues as part of that technical assessment, starting next June, another one in November, and then another one the following June, before the final high-level conversation around the global stocktake at the end of 23 at our climate change conference. And each of those technical dialogues will cover the themes of the global stocktake. All 3 will be led by co-facilitators that are decided upon by parties. The IPCC assessment report is a major part of this conversation, and there'll be separate dialogues to better understand the IPCC outputs from the AR6 and how that feeds into the process. Next slide, please. So why is this all important for the Earth observation community, you're asking? Extremely. And it's also important, the GST is important for the Earth observation community, and the Earth observation community is extremely important for the global stocktake. I say in just about every presentation I give that Earth observation is the foundation for action on the Paris Agreement. It's the basis for our understanding of what's going on in the climate system. It's the basis for actually making decisions around how we mitigate and adapt to climate change. And it'll be the basis for this global stocktake and our understanding of where we are at an aggregated global level. So it's important that the Earth observation community is engaged, provides input into the global stocktake, that we're still in a learning by doing phase. It's the first time that this has ever been done. So of course there's some understanding of where we need to go, but also there's an opportunity to provide an input that's a basis for where we move to in the future. And the better understanding that, you know, the Earth observation community is, as we discussed yesterday and at the national level, and we'll discuss today, there's a huge opportunity for the Earth observation community to provide a better understanding of how important it is, as well as how it can help parties mitigate and adapt to climate change, and how aggregated level this information can be collected. So here are just some examples of what the questions that need to be addressed in the global stocktake under the different themes. And as some know on this call, the observation community is working together right now to provide a synthesis input into the global stocktake to address some of these issues, to address the questions that the global stocktake can have on these themes. And it's important to look at that in terms of how the Earth observation community is helping, or who it's helping at the national level, examples, as well as the information, like we said, at the global level to look at where we are exactly. So the final point on this is that the first phase, where the synthesis report will be inputted into, there is a deadline for that paper, sort of in the early part of next year. So there's a little bit of hard work to be done between now and then. But I'm also confident that GEO has a huge role to play in its support to the global stocktake, as well as its support at the national level. And the Secretariat is here to fully support the GEO community moving forward in that engagement. And with that, thank you very much, and I'll pass back to Sarah.
Thanks, Joanna. And it's important to have a clear understanding of what the global stocktake actually means, and the complex system behind it, and that the GEO community and all the partners are part of this process. So I would like to turn to Thelma Krug now, IPCC Vice Chair and Chair of the Terrestrial Observation Panel for Climate of the Climate Observing System, GECOS, to tell us how the IPCC is actually informing the global stocktake and how the Earth observation community can support the gaps that have been identified in IPCC reports lately. Only a few words, Thelma, and we're happy to hear from you.
Thank you very much, Sarah, and also hello to everyone participating in this workshop. So I also thank GEO to have invited me to come and provide some lines of thought, I would say, as Vice Chair of the IPCC and also Chair of the TOPC, which is the Terrestrial Observing Panel on Climate. So I don't have any slides, so I'm going to touch on some points that I hope will be helpful to our conversation. And as Joanna has just indicated, just last month, the Ipcc had approved and released the contribution of the working group 1, the group that focus on the physical science of climate change. And it's usual that in the Ipcc reports, 2 more are coming in February and March, as also Joanna indicated in her slide. And it's usual that the Ipcc identify gaps in knowledge. And these have been quite helpful to indicate to the scientific community, but not only the scientific community, because the scientific community relies on data. The modeling community relies also on data, which I hope to be able to comment in my presentation here. So, but obviously in the chapter 1 of the working group report, we have a table that really provides elements of information that has been assessed by the Ipcc. That Ipcc doesn't do the research, but it assesses the literature worldwide on the relevant issues to the climate change. And so many of the assessed information that you see in the Working Group 1 report can be of potential relevance to the 2023 global stocktake, but not only to that one, but also to the future years, 5 years, gap stocktake under the UNFCCC. So in particular, I would single out the information concerning the remaining cumulative carbon emission budgets that is provided by the Ipcc for a range of global warming levels. And this can be a reference for the evaluation of the evolving global efforts to mitigate climate change, adapt to climate change, and as well as an alignment of these efforts with the Paris Agreement. But also this table identifies several questions of potential issues that could be relevant. I'm going to just single out 2 of them. One of them is how much warming has been observed in global mean surface air temperatures. And answer to this can be very helpful to quantify the remaining distance to the Paris Agreement long-term goals. Another one is how much have atmospheric CO2 and other greenhouse gas concentrations increased. And answering this is also crucial to assess the pathways of greenhouse gas emissions compatible with the Paris Agreement's long-term goals. So as I said, these are just a couple of examples of assessed information by the Ipcc in the Working Group 1 that can be helpful to the global stocktake. Also, the information that has been assessed by the Ipcc, which in the literature, as I mentioned, worldwide, uses a range of data sources. And many of these come from a number of different satellites that observes land surface, atmosphere, ocean, cryosphere. And there has been progressively improvements on not only on the quality, but also on the quantity of remotely sensed information available. And I singled out one of example that became available in the last Ipcc cycle, the AR5 2014, on the Greenland and Antarctic ice sheets, for instance. At that time, before the AR5, before 2014, the researchers lacked sufficient data to tell whether the ice sheets were shrinking or growing. And through a combination of satellite data and other measurements, a consistent signal of ice loss for both ice sheets have been established. So, so we can see how the satellite information is being relevant for many, many types of information. So it has also, satellite data has also revolutionized studies of the cryosphere, particularly near the poles where conditions make surface observations very difficult. So progressing climate science relies on the quality and quantity of the observations from a range of platforms, including obviously the satellites, because they provide observations of a large number of key atmospheric, oceanic, and land variables. Well, presently, as Sarah showed in the introduction, I also chair the Terrestrial Observation Panel on Climate, the TOPSY, which is one of the 3 panels under the Global Climate Observation System, the GEOs. And the other 2 panels focus on atmospheric and oceanic climate information. So one of the tasks is to evaluate the essential climate variables, they called ECVs, data sets, which are required to support also the work of the Ipcc. So the terrestrial ECVs can be subdivided in hydrological, cryosphere, biosphere, and also anthropogenic sectors. And many of them are observed well from space, with in situ observations providing validation, although much more is needed, and so have a good global coverage apart from some polar regions. Just before I can finalize, Sarah, if you allow me, I'm going to single out some of these essential climate variables for which a need for improvements have been identified. So since you're talking about gaps, and let's see if I can contribute to that through the ECVs. So for instance, for soil moisture, we need to improve the accuracy in areas of dense vegetation, permafrost, organic soils, regions with strong topography. So data are there, but they need to be improved. For the hydrological cycle, we need a satellite mission that is dedicated to measuring, for instance, evapotranspiration to improve water budget closure over tropical areas. Maybe these do not come necessarily from Earth observations, singling out some data satellite needs. For the glaciers, satellite data globally covered, but has too low spatial resolution to extract useful data with sufficient temporal resolution. So some data are available also from Earth observations, but not necessarily at the temporal and spatial resolutions. For snow, for instance, large uncertainties, particularly in mountains areas due to lack of in situ observations for data calibration and validation. Above ground biomass, which Earth observation satellites help a lot, but currently the satellite-based radar and LiDAR methods cannot resolve the highest biomass concentrations, in particular for the tropical countries or regions. But we are expecting to have new missions coming up that we hope will overcome this issue. Fire products are also an issue. Uncertainty, most of the time underestimation of burned areas, particularly in regions with high dominance of small fire patches. And finally, some soil carbon. There are consistent observations across the globe, but these are based also on soil carbon on in situ observations, not routinely or frequently repeated. So the changes are not well monitored on a global scale. So we need some improvements on that as well, and also observations of other carbon pools in vegetation and soil. So this is still underdeveloped. But to finalize, Sarah, I'm going to single out 2 issues that are recurrent in the discussions we have at GEOs. First one is the need to ensure the long-term continuity of some satellite observations. So this is really crucial because some of the data for the long time series rely on a specific data provided by satellites, and we need to have continuity on that. Also, data rescue of early missions that could allow data series to be extended to the past. And in particular for the Ipcc, this is quite relevant. But obviously these depend on sustainable support for these activities. And obviously would like to say that CEOs is part also the discussions with Chicos, and so they are following up with the needs and where we need to have improvements, not only for the terrestrial observations, but also atmospheric and oceanic. So I hope with this I could contribute a little bit for the discussion, singling out the importance of the satellite data that has been increasingly improved, but also some depths still remain, and we are hoping that this will be overcome in a short time period. So thank you very much for the opportunity, Sarah.
Thanks, Thelma, and it's really helpful that you have identified the challenges in Earth observation. I'm sure the next presentations will provide at least some initial reflection on how space missions can address these gaps. So next I'm turning to Federica Bietta, Managing Director of the Coalition for Rainforest Nations. The Coalition for Rainforest Nations has recently joined GEO as a participating organization, and Federica will tell us about developing countries' needs for collective ambition, in particular with regard to the REDD+ mechanism. So Federica, over to you.
Sarah, thank you so much, and good morning, good afternoon, everyone. A pleasure being here and be part as a newcomer of the partnership with GEO. I'll be pretty fast on my slides and trying to catch up on some of the time as we're running late. But here, so I was asked to make some just keynotes on ambitions and connections also on the REDD+. So here are slides that probably many of you are all familiar. So how bad we need to reduce emissions to really keep avoiding the increase of temperature to 1.5 or 2 degrees, like also Joanna showed us in the first temperature. We really need to act faster. We need to have a big, nice dive, nose dive, if we look on the slides that we have now on the screen. And really, we have about 9 years really to act as fast as we can. So what we need to do is really to bring the emission to net zero by mid-century. And that means reducing between 65 to 90% of the current emissions from 2020 emission to by 2050. And that means that in the next 9 years, at this point by 2030, we need to reduce by 50 to 70% of what are the emissions currently. In the next slides, we'll see though that these nose dives is possible to do it. There is some hope. And the hope is really provided by the REDD+ mechanism that has been captured into the Article 5 in 2015. And this is the only mechanism at the moment that has been finalized and can provide reductions at scale at the global level. What is it? So there is about 90% of the world rainforest are working, embrace the REDD+ mechanism. That means over 60 countries submitted national strategy to the UNFCCC for their emission reductions from deforestation, degradation, and the conservation, increase of carbon stocks, and all the activity comprehensive in the REDD+. And so the other good news, what it is that from 2010 until today, about 9 gigatons of carbon reductions have been achieved by rainforest countries. So those are very good news, but there are limits to that. In the next slides, we'll see what is the big limits. As we're talking about finance, that of the 9 gigatons, the rainforest countries have reduced as of today, about only 4 and 5% have been paid for. And so there is a gap really on finance. If we go in the next slides, there is a gap and support in the countries on the final results that they present that they need to be paid, and so we saw increase really from the 4 to 5% to bring it to the feel like gap with the 95%. But there is a gap also and challenging on the first part for those countries to be able to produce these reductions. And so we have really a great mechanism with the RED Plus, but needs to be capitalized on the far front and at the end of it. It's very important we saw for the global stock take that we have reliable data. At the same time, for the countries to be able to bring their inputs at the stock take, that means they need to have reliable data, they need to be transparent, they have to be consistent, and they have to be accurate estimate of both their emissions and their removals. And so that's also where GEO comes in and can help, and all the community together. The satellite data information, as also Thelma just briefly present us, that there are more and more available and more they're coming. The challenging part is that those satellite data needs to be confirmed with the systematic collections in situ on the ground. And this one is really very costly and time consuming. And that's where really rainforest country needs support on this side. Not only that, but there is also an enormous amount of data that needs to be stored year after year. And that's very costly as well. It needs to be stored so that it can be a comparability, year after year. And so really, GEO and all the community observation can really help to fill some of the gaps, especially also with the capacity building. That is one of the key elements to really move forward, and international cooperations as well is going to be very important. And on the last slides, I just want to briefly show that the partnership that CFRN, GEO, INPE put together to support the pilot project in Mozambique, where we are doing a wall-to-wall map from 1990 and 2019. And we're doing a technology with spatial resolution about 30 meters. The challenging part again is the in situ data to collect, but with the government of Mozambique, we have been making really some good progress. And we hope that this pilot could be really replicable in many other countries of the coalitions. And so we're looking forward to strengthen further our cooperation with GEO, with INPE, and other institutions that will be, working on this space. I thank you, Sarah, and thank you, everyone.
Thanks, Federica, and for confirming the importance of working with countries to validate data from satellites. And we too hope that we can scale up this pilot project to other countries in the coalition. So this keynote ends the first session, and we now can turn to Earth observation data providers, the satellite-based Earth observation, notably, to see where the current and future capabilities lie to support the global stocktake. So quickly, I will introduce Veronica Neumeier, a consultant at the GEO Secretariat, Aaron David, a remote sensing analyst at WatTime, Barbara Ryan, Executive Director at the World Geospatial Industry Council and former Director of the GEO Secretariat, of course, and they will tell us about a joint effort by our three organizations to map the existing capabilities for greenhouse gas monitoring from space. Veronica, over to you.
Thanks so much, Sarah. And yes, many thanks for the opportunity to be able to present this joint effort on developing our report under the working title, GHG Monitoring from Space, a mapping of capabilities across public, private, and hybrid missions. And as you can see in the slide, while we're working on this, so actually this effort stems from a high-level virtual event that took place last December 2020 under the support of the former US Vice President Al Gore and the current UK high-level climate action champion Nigel Topping, in order to support the race to zero for COP26 And so in this 100 people stakeholder event, we actually got one very clear ask out of this forum, which was the need to support a better understanding of EU capabilities to contribute to national and global processes. So the national GHG inventories, but also the global stock tag, by providing a fuller picture of the current, but also the upcoming GHG monitoring capabilities from space provided by public sector, but also private sector entities. So what are we trying to achieve with this work and how are we getting there? Over the past few months, we've at the GEO Secretariat, the World Geospatial Industry Council, WGIC, representing the private sector, and what time a private sector company within the Climate Trace Coalition have been working together jointly to develop a comprehensive database and report with the objective to actually develop a very first systematic overview of these mission capabilities that relate to the GHG gases under the UNFCCC convention. We utilize actually the ZEOS database as a starting point, adding different peer reviews and other mission information in a simplified or in a translation way, and added the private sector contributions to this database. And at this point, I have to say many thanks to some ZEOS colleagues on the call and other colleagues who've been already contributing to this effort. So overall, we want to support the race to zero and also support policymakers on the national level and reporting to the UNFCCC to use Earth observation in a more concise way. And I'm handing over to Aaron.
Thank you, Veronica. So thank you. And here's what we created based on the methodology laid out in the previous slide. So let's begin with the image on the left. This is a subset of what the consolidated database looks like. So working together, we consolidate different information sources to create a GHG monitoring capabilities from space database. We primarily use the CEOS database, incorporate mission websites, peer-reviewed articles, in addition to reaching out to private organizations to fill in the relevant information we created here. Currently, we identified around 40 past, ongoing, upcoming missions relevant under the UNFCCC. The database here contains the following high-level categories that I'll describe. First is the mission ownership, identified as public, private, for example, GHGSat, and hybrid missions, which are joint efforts between the public and private sectors, for example, Carbon Mapper. We identified missions that collect one or more of the relevant GHGs established under the UNFCCC, rather than in direct measures of GHGs. Now, for each mission, we provided the status, identifying the satellites in orbit, in development, or end of mission, the mission goal, which describes the overall objective of the mission, and if there is a specific mission goal relevant for climate change mitigation, what greenhouse gases are observed. It was carbon dioxide, methane, nitrous oxide, and ozone. Scale of application, which is at what level can GHGs be measured? And we identify three general scales, which are point source, define a single identifiable source of GHG emissions. And this is going to vary based on the sensor employed in each mission. National level, define a state or province level, and then global level. Additionally, we provided data access, which describes if a mission's data is open source or requiring registration or paid subscription. And then lastly, we also incorporated relevant information sources, links to those sources for each mission. Now, taking this consolidated database on the left, we create a stylized version of this database on the right. And this stylized database is meant to help bring the main points and information across. And both types of databases will be featured in the upcoming report that's being worked on. Next slide, please. So here we like to present some preliminary findings that can form today's workshop, but also inform a wider discussion around the global stocktake. So the first chart here on the left is mission status by country, meaning a breakdown of missions that are in orbit and currently collecting data and in development. And these are represented by the green and yellow bars, as you see. Additionally, we include a breakdown of mission ownership, identified as the blue, red, and purple color bars, that identify whether the mission is being led by the public, private, or hybrid sector, and how many are being developed by each sector. The second chart highlights the number of missions monitoring specific GHGs and by sector, both in orbit and planned. And so here are a few highlights from the first chart. The public sector represents the bulk of the missions that monitor GHGs currently in orbit, indicated by the green color bars. And there is a lot of activity in the public sector of future missions. But in some cases, the private and hybrid sectors, represented by the red and purple color bars, represent all or majority of future missions for specific countries or joint efforts between countries. And for the second chart, the public sector is strong in monitoring all greenhouse gases at the global and national level, represented by the blue color bars here. Additionally, in the second chart, the private sector does monitor all for greenhouse gases in some capacity, but there is more specializations toward monitoring specific gases such as methane, and the hybrid missions are similar to the private sector. Now, not highlighted here, but worth mentioning, the private and hybrid missions are directed more towards point source monitoring of missions. So the joint report being developed will give a clear overview of the strengths different sectors have with monitoring greenhouse gases, and the database will be used to derive some key messages for this report. Now I'd like to pass it off to Barbara Ryan for the next slide.
Thanks, Aaron. And listen, we'll go real quickly through these key messages. First of all, that Earth observations from space reduce uncertainty in emissions. And I think we heard both from Thelma and Federica that this point is important. We're increasingly getting more data, and we need that additional data if we're going to reduce those uncertainties. Clearly, the role of in situ measurements is going to be critical. You also heard that from Federica and Thelma also, and that will continue to be real important. But I think what we're finding is that the top down and the bottom up is just going to be as essential as we go forward. Aaron mentioned that public space agencies are just collecting a lot of data. In fact, we often think about them as the workhorses in this entire field, not just for greenhouse gas monitoring, but for all Earth observations. And in addition to CO2, methane, and all the greenhouse gases, the spatial scale at which they collect data is just really important. Nationally and globally, those workhorses deliver that data. They are increasingly showing high emitters, and that's really important. But that's a good transition to the next key message, which is the private sector companies are increasingly entering the market with good point source monitoring capability. Now, I want to be clear, there is only one private sector mission in orbit right now, and that's a Canadian-UK mission called GHGSat, but there are several, in fact, I would argue maybe many private sector and hybrid missions in development. The hybrid missions that Aaron mentioned are increasingly emerging, and I think this was a surprise for us as we put this work together. Clearly, they're leveraging each other's strengths, so whether it's public sector, private sector, or not-for-profit hybrid models, again, in development, those are really important. The countries that are participating in those hybrid models are Canada, the Netherlands, Spain, and the United States. Each of the previous speakers, I think, mentioned this next point, that collaboration, innovation, and financing are just going to be key levers for GHG monitoring from space. I would argue they're going to be key levers for any Earth observations that are going to address the challenges that we've been talking about over the last couple of days. And then lastly, open data, open science, and open knowledge are just essential. The business, let's be clear, the business models are different. For public sector organizations that is paid with taxpayer support, many organizations, GEO, CEOS, have been arguing for a long time that data needs to be open and available to all taxpayers. The private sectors have different business models, but as they start to migrate towards applications, versus data. I think you'll see some of that data, those data pricing models change. And then lastly, those hybrid models, I think, are going to be really important as we look forward, because when you're mixing both private sector and public sector resources, we might start to see more open data come out of those private sector missions. The last thing is you'll see on this slide a link. So when you do get this presentation, click on that link. There are about a paragraph of more description behind each one of these key messages, and we'd like additional input on that. Sarah, we'll turn it back to you. Thanks an awful lot.
Thank you, Barbara. And Veronica is going to share the link in the chat now, so everyone can have access to it before we share the presentation. With that, we will have a good overview of the capabilities, but I will turn now to David Crisp to hear more about what CEOS is doing. David Crisp is a senior scientist at the NASA Jet Propulsion Laboratory at the California Institute of Technology and leads the effort of the Committee on Earth Observation Satellites around greenhouse gas monitoring. And he will tell us how this is supporting climate ambition. Dave, over to you.
Good afternoon, everyone. I hope everybody can hear me well. I'm going to make a quick run through an activity just to demonstrate some of the capabilities that we have today and to actually move into the future with some additional capabilities for monitoring. So if we can go to the next slide. As many of you know, as we begin the process of going through the stocktake, one of the first activities is to compile inventories of greenhouse gas emissions at the national scales. And the nations around the world have started down this track, developing these bottom-up inventories of emissions and removals of carbon dioxide, methane, nitrous oxide, CFCs, and other critical greenhouse gases. It turns out you can also monitor greenhouse gas emissions. No, I should say that these inventories that are being developed by nations are not being developed from direct measurements of greenhouse gases in the atmosphere, but instead being developed by counting the number of barrels of oil that have been used or delivered, the number of kilograms or kilotons of coal that have been delivered, and then using emission factors in order to estimate the amount of emissions into the atmosphere from those totals. These particular methods can be extremely accurate in certain areas like the main fossil fuel emissions, but not so accurate when you're trying to count the number of acres or the amount of carbon emissions from a certain number of acres of forests that have been converted to farmland, let's say, okay? But fortunately, there are other ways to make measurements of emissions of carbon dioxide and methane into the atmosphere. As you've already heard, you can make measurements of the actual concentrations of these greenhouse gases in the atmosphere at very, very high spatial and temporal resolution, and then analyze these data with something called atmospheric inverse models to actually derive national scale budgets of the net emissions of carbon dioxide and methane in particular into the atmosphere and the removals of those gases by the natural biosphere. And so those are capabilities that exist today. These particular approaches complement the bottom-up methods that are being used by the individual nations by providing an integrated constraint on all emissions and removals. They're not as source specific, so we can't always say that this particular kilogram of carbon dioxide or methane that was added to the atmosphere came from this particular process, but we can tell you the net effect of all processes. So go to the next slide, please. What do these inventories look like? We're actually, in order to demonstrate this in a very concrete way, we actually generated a series of inventories for methane and CO2 for nations of the world using the available data from the In-Situ network. These are ground-based stations that measure carbon dioxide, methane, and all of the greenhouse gases. And there are about 120 to 130 of these scattered around the world that we're using at the moment. And then we also used the data from the Orbiting Carbon Observatory 2 spacecraft for carbon dioxide. Now, there are several other options as we move into the future, but these were available today. We use those in order to, in an inverse modeling format, to calculate the net carbon exchange on nation levels. And what we can see here in this chart is just an example of one way to present the data from that, nation by nation, showing fossil fuel emissions, the lateral transfer through rivers or through crops and wood. We can also look at the net carbon exchange from the biosphere, and we can also then add those numbers together to give you the total net carbon exchange. So that's basically the way these inventories work. And this is what one looks like for carbon dioxide. And we go to the next slide. We've done the same thing for methane. So we've looked at top-down observations. We found that with the existing methane satellites, we can constrain the methanes for about 58 of the larger countries around the world. And as time goes on, we'll be able to actually produce results for smaller and smaller countries and smaller contributors to the total methane budget. About 5 countries are responsible for about half of all of the anthropogenic methane emissions, and most of those emissions are coming from the agricultural sector, primarily from livestock, and wetlands are the other major sector, a more natural sector. So we're continuing to go forward with these kinds of things, and we're going to be putting these inventory products on the table starting at COP26, and we're just finalizing the results and the documentation of these materials in a race to produce a good presentation at COP26. If we go to the next slide, the main objective of these products isn't necessarily to provide a monitoring and verification system. We're not quite ready to do that, but we're ready to show people what can be done in the future as we move forward in future stock takes. So the main objective of these materials that we're putting on the table today are to start a really serious conversation between the various stakeholders, including the UNFCCC and the Ipcc, and the users of these data, the national inventory agencies. What are the best practices? What are the best products that are available? And how can we get these out to the community? How can we start this conversation and start to develop the detailed requirements that we need to use these products as we go into the future? And I think that's all there is. Thank you very much. And we'll jump into the next speaker.
Perfect. Thanks, Dave, for keeping it very concise and for providing the overview of what CEOS is doing to support the global stock take. We now turn to the next speaker, again with the request to be very, very quick, so we leave time for a good discussion afterwards. Andrew Zolli, Vice President of Sustainability and Global Impact Initiatives at Planet. He's also representing Carbon Mapper, who was mentioned, that was mentioned in the mapping exercise that Veronica, Barbara, and Aaron presented. Andrew will explain how commercial missions are aiming to accelerate global coverage for Earth observation. So I'm turning to Andrew.
Thank you very much, Sarah, and hello, everyone. In the interest of being concise, I will try to move very quickly through just a couple of key points. First of all, my name is Andrew Zolli. It's a pleasure to be here with you. I oversee sustainable development work here at Planet, and I would just like to say we're implementing a wide variety of activities that are designed to support the goals and ambitions of the global stocktake and the broader set of enabling climate action that many of you have discussed today, and I'll make reference to a few things that have been already mentioned. Could you go to the next slide, please? For those of you who may not know Planet well, I'll just say, please, if you could run the animation. We're largely known for having deployed a very large constellation of small satellites that produce a daily 4-band continuous observation of the entire terrestrial surface of the Earth and the near oceans. We do that at roughly 3 meters, a little more than 3 meters per pixel per day. And then we operate a large constellation of smaller satellites, of higher resolution satellites that can image selectively anywhere on the Earth up to 10 times a day at 50 centimeters per pixel. And we use these two sets of instruments and some others in development in conjunction with one another. The resulting data set has very high temporal resolution. It has moderate, the daily take has moderate spatial resolution, but the ability to leverage the time axis for action is a really significant component of our overall strategy. Many of the instruments that we currently use to support these activities produce data assets that are very high quality in terms of radiometric calibration and the other things that the core data that's being observed. But they do so at lower spatial and lower temporal resolutions. Our intention always is to complement the existing capabilities and to find opportunities to turn this privately collected data into public assets that can then be used to galvanize action. So if you could go to the next slide, please. I'll just give you a simple example of this. There was some discussion earlier from our colleagues, one of our colleagues speaking about the Rainforest Alliance countries and the RED Plus program. We have a relationship as an example with the government of Norway in which they finance us and several other partners to provide data that we comprehensively collect over 64 countries across the equatorial belt. This very high resolution 3-meter data on a wide variety of formats. The data doesn't live with Planet. It goes from Planet to the UNFAO through a platform they operate called CEPL. It goes out and is made available to the ministries of forestries for all of these countries across this wide band. And you can see it includes very significant and highly relevant geographies for monitoring and reducing emissions from tropical deforestation in particular, and is intended to become, I'm sorry, could you go back one, please? Just before I get there. This data represents a strategy for us as a private sector organization to try to transform these private assets into digital public goods. And so one of the things I want to just reference is that there are, as I think Barbara mentioned, there are existing and forthcoming missions. There's a lot that's happening, as Aaron mentioned, in the private sector. And one of the muscles that we've been working on is how to develop the right financing and partnership apparatus to transform the value that's in the private sector into value that's made available to all. And in particular, we think essential for both driving general climate action as opposed to just climate reporting, to provide the kind of temporal frequency that's required to guide action, but also to make sure that the barriers to access are dramatically reduced. If you could go to the next slide. The satellites that we produce that operate on a daily basis, which we call doves, are actually being upgraded at the moment. And I wanted to just mention this as an example of another way in which the private sector can complement the extraordinary capabilities and investments that have been made in the public sector at sort of national asset level. Our satellites that image daily are today 4-band satellites. They image in optical and near infrared. But as we developed our technical roadmap, the first way stop for us was to produce daily continuous multispectral imaging. And so one of the things that you'll see here at the bottom, at the top row are the Sentinel-2 spectral bands. At the bottom are the spectral bands of our next generation satellites, which are called super doves. Our current constellation are called doves. And what you'll see there is a very intentional alignment, say, of the spectral bands of our satellites to Sentinel-2, primarily to extend the utility of Sentinel-2 and to allow our satellites to more effectively produce data that can fill in temporal gaps and essentially complement those assets that are already public goods, that are already producing these kinds of values. This represents this sort of technical alignment, in addition to partnership, I think represents an additional pathway. Next slide, if you wouldn't mind. Thank you. And then as has been mentioned, we're a core partner with JPL, with the state of California, the Rocky Mountain Institute, a number of other NGO partners. in the development of Carbon Mapper. For those of you who may or may not be aware of this, Carbon Mapper is a forthcoming system that takes a hyperspectral instrument developed at Jet Propulsion Laboratory, and in 2023 we'll put up 2 of these instruments. One that is specifically focused on is the current JPL. This is a 400 band instrument. Its first canonical use case will be in the detection of point source emissions at very high spatial resolution and at very high degrees of sensitivity at the facility level for methane. And so, but the instrument has hundreds of other relevant bands of data that we'll be collecting that has exquisite relevance for measuring things like biodiversity and countless other use cases. So the thing that's interesting here is that this represents a technical partnership at the non-national level between private philanthropy at the significant national scientific institutions, state levels, private sector, all of that data. One of the things that we've set up is a nonprofit so that the methane emissions data will become a public good and widely available. And here, one of the things that is a sort of a general strategy for the things that we try to do is always to establish the right kinds of governance structures. And so where we can work with the wood grain of existing governance structures, support the existing architectures and those entities that have the right provenance and mandate and right kind of international standing, and where necessary, and only where necessary, establish independent, nonprofit governance of the data so that it doesn't sit solely in the private sector. I could say a lot more about this, but I'm trying to race to meet Sarah's deadline. One thing I wanted to say that we're really excited about is that we're also directly supporting Climate Trace, and our one of the things that came out of the last workshop actually was a direct bilateral discussion between us and Climate Trace and former Vice President Al Gore, and that's led to a very significant data partnership. The one thing I would just leave you with is that we see a significant opportunity for the private sector to provide complementary capabilities that enable especially action taking. We need to do a global stock take, but in between the global takes, we need to enable individual action precisely in time and space. And that's a place where our capabilities, and I don't mean our at the parochial level, at the organizational level planet, but our level at the private sector, that's a place where I think we can add significant value and make sure that we are actually delivering real progress. In closing, I'll just say one last thing, and that's that we're becoming more intimately involved in the GEO community. We're really thrilled at the work that GEO is doing and very keen to collaborate. We have multiple parallel efforts that are also going in areas of, say, biodiversity and the enablement of indigenous communities to play a significant role in these activities as well. So, there's a full spectrum of things that are happening, and it couldn't be more exciting. Anyway, I'm thrilled and honored and humbled to be here with all of you today. So thank you. And Sarah, I'll just pass it back to you.
Thank you, Andrew. And so it's so interesting, and your messages on complementarity are, of course, what we are also aiming with the mapping report. We are also excited to start a new collaboration with you, of course. But speaking of methane monitoring, I would like now to turn to the next speaker, Manfredi Caltagirone, who leads UNEP work on methane emission in the energy sector and is acting head of the International Methane Emissions Observatory, IMEO. And Manfredi will give us a perspective on concrete collaborations with the oil and gas industry for greenhouse gas monitoring that goes even beyond the global stocktake. So Manfredi, over to you.
Thank you so much, Sarah. And I'm in a comfortable situation of being in between you and the discussion that is going to be more interesting. So let me try to be really, really quick. But so if we go to the next slide, the objective of IMEO is really to accelerate methane emission reduction to the level and speed required by the climate crisis and the Ipcc report that just came out, the AR6. and intends to do so by creating a global public data set of empirically verified methane emission from oil and gas installations, and eventually coal, and eventually other sector. So to create a common language that can be used by different stakeholders to create policies, to target measures, and to, in the case of industry, for example, but also to hold stakeholders accountable for their commitment. So the role of IMEO is really to indicate what is being emitted, where is being emitted, and how much is being emitted. And IMEO is going to do this by taking an approach that is really collaborative, and it fits well after Andrew's presentation that very much focus on complementarity. IMEO intends being complementary to other initiatives, but also to be able to integrate and catalyze action that is happening across the ecosystem in a way that again accelerates methane emission reduction, in particular from the energy sector. That is where most of the reduction potential lies. So if we go to the next slide, Sarah, the IMEO will be taking data from 4 main data streams, and we're going to try to very quickly look at them and see also how the GEO community can contribute to it. And we have a lot of ideas, and we hope that you'll be interested in engaging with us in the next month. So if we go to the next slide, the first stream of data will be company reported data under the Oil and Gas Methane Partnership. There is 2.0 actually. That's the new reporting framework. It was launched in November of last year, 2020. The OGMP covers around 30% of oil and gas production globally, and companies have committed to reach a very high level of granularity and accuracy in the data that they will be reporting, following a framework and methodology that we have jointly developed with NGOs, governments, and the industry itself. If we go to the next slide, we'll see how the OGMP currently covers all continents of the world. OGMP companies report both their operated asset emission and non-operated asset emission. The OGMP covers the entire value chain, so downstream, midstream, and indeed upstream. That is where we know most of the emissions come from. So bottom-up data reconciled with top-down level. At asset level, the data will be confidential. We only be able to share data at company level, but we're going to be able to use these data to integrate them with other sources, and in particular, if we go to the next slide, with the data that are being derived by measurement studies that we're funding. We have been running as UNEP the methane science studies under the CCAC that have already developed, produced a number of scientific papers that have been published in peer-reviewed journals, analyzing methane emissions from different geographies and from different sectors, so from different part of the oil and gas value chain. We're currently doing studies or preparing to do studies in Central Asia, in the Middle East, and in West Africa. We're looking for opportunity to do additional measurement studies in the other jurisdictions that you see with the green dot. If we go to the next slide, indeed, satellite observation, remote observation will be a critical piece. This is just a few examples of the satellites that are already operational or will be operational in the near future. And indeed, satellite observation is a game changer in this space, but we believe that it is important not only to have data about high level of emission events, but also to be able to connect this observation with the reality on the ground, and this is what we'll be able to do using OGMP data in parallel with remote observation data. We already have a partnership with Tropomi We'll be working with Meet and Sat from EDF. We are looking at establishing a partnership with GGSat, but we are really not constrained by the number, and we are hoping to be able to tackle the experience and the data that your community has. So to be really able to generate, and if you move to the next slide, Sarah, this public data set of empirically verified meat and emission information at global level. This is obviously less simple than it sounds, but we intend to partner with research organization and university, as we are doing, that have a lot of experience, much more experience than the UN in doing this. But we believe that it is important for the UN to be the host of this for a number of reasons. One is to ensure independence from any government. Second, because of our confidentiality ability compared to national government, that give confidence to oil and gas companies that they can share data with us in a safer space. But also because it's really the INEO will only be successful, if we go to the next slide, if we manage to connect the different element of the ecosystem through this common language that data can represent. And specifically the science, the transparency, and the implementation, the communities that are critical, and again, in a complementary way, not in a replication way, we intend to engage with them and provide them with the instrument that they need to achieve these mitigation actions. So thank you so much, Sarah. I hope it was quick enough, and I look forward to the discussion.
Thank you, Manfredi. We're only 10 minutes delayed, but we can have a meaningful discussion now. So I invite all the speakers of this session to turn on their cameras, and I want to introduce Mark Dowell, Senior Scientific Officer and Project Leader for Scientific and Technical Support to the Copernicus Program at the European Commission Joint Research Center. Mark is also Chair of the GEO Climate Change Working Group, and is going to moderate the discussion today. We have a couple of guiding questions to steer the conversation. So first question is, how can the broader Earth observation community involving both public and private missions effectively support the needs around the global stocktake that your presentation already addressed, but we can elaborate on that. And then about the capabilities, how the current capabilities should be exploited and what additional capabilities should be developed, and generally the contribution of the Earth observation community to the global stocktake should be better defined after this conversation. So Mark, over to you.
Thank you very much, Sarah, and thank you very much to all of the speakers. I think that has provided a very strong basis for our discussions now. So as Sarah mentioned, we have these two guiding questions. I think what I'm going to do is I'm going to actually split into two groups to ask you these questions. So I'm going to ask or give kind of various interpretations of the first question in asking points to Joanna, Thelma, Federica, and Barbara. And then I'm going to come to the second question and ask from various points of view to Dave, Andrew, and Manfredi, if that's okay. So Joe, starting with you, and I have actually a couple of smaller questions to you, so I'd be grateful, as to all the others, if you could answer them as succinctly as possible. And I know you followed yesterday's discussions as well a bit. I think one thing, and I realize, as you said in your own talk, this is kind of learning as doing, but one thing that I think is interesting is any opinions you can, or additional points you can make on how you see Earth observation contributing to this bridge between the national reporting aspects of the global stocktake and then the collective ambition. So what we're dealing with perhaps more today. So this kind of layer of contributions that could come from the Earth observation community to that. And then two very rapid questions, which you can perhaps add on at the end, is First of all, and this is more for the benefit of our colleagues from the private sector, if you can give any indications, maybe from your point of view in the Secretariat, of how you see private sector contributions coming into the process. And then more to the GEO community, I think those of us who have been following this have seen, both in these land and ocean dialogues you've had, recently a lot of emphasis on biosphere aspects, and this is obviously a strength within the GEO community, both for land and ocean. And so maybe if you could just say a couple of quick words on that. So if you can address these points, I'd be grateful. Thank you.
How long have I got, Mark? Okay, I'll try and do it in a very short space of time. The international national link. So the global stocktake is an aggregate of information globally, whether that be temperatures and climate indicators, so the basic observation information, but it also needs to be an aggregate of action and implementation of the Paris Agreement, which is the priority for the global stocktake. And that implementation is obviously done at a national level. So it needs to find a way of bringing what's going on at the national level to an aggregate at international level. And that can be done in a number of ways. For mitigation, it's obviously will be based around GHG reporting, but that GHG reporting is obviously supported at the national level by Earth observations. And I think there's a very exciting times coming in the Earth observation community to strengthen that support. Currently, it's done through statistics agencies, but as we go forward in the Paris Agreement, every single country will have to do GHG reporting. There's places where that could be strengthened, and that strength could come from the Earth observation community to do that. So at this first global stocktake, it could simply be, this is the number of countries that are doing this, this is the number of countries that Earth observation is supporting in this work. But moving forward, as we heard from Dave, there's obviously great things ahead in terms of increasing this support. Similarly with adaptation, that's a little bit more complicated, as we all know, in terms of providing information for and on, as in collective progress on it. But again, there are indicators that can be provided by the observation community to measure, to look at how adaptation is progressing, and then use these at an aggregate level internationally. And again, how many countries are GEO supporting in their work on adaptation? How many do they intend to do? What are the examples, and so on? The biosphere is extremely important. It's a big topic this year. Obviously, the food summit's coming up. We've had the IUCN conference. We've got the CBD post 2020 coming up. It's a big issue. We all know that we live in one Earth system. We have one planet. So we are not separate from nature. We are a part of it. And so this message really needs to become more strong within the UNFCCC conversation, alongside a strengthening of the ocean conversation within the UNFCCC. We are one system, and there is the ambition for reducing emissions needs to go along the side of how we are going to mitigate and adapt within the ocean and land space, and the connections between the two, and between biosphere. So it's important that the Earth observation community provides this information for this sort of decision making. In terms of link with the private sector, yes, extremely important. It's really interesting to hear what's going on. Well, I'm obviously in contact with Barbara and GEO on all of this exciting information. And I think it's important that to emphasize that under the UNFCCC, that the trust issue is extremely important when supporting parties in their GHG reporting. So there needs to be as Andrew very clearly explained, we need to work with the systems that are there, so that the opportunity then is for this work to support countries in their GHG reporting or in their work on adaptation, and to bring that synergy in together. And I tried to do that as fast as possible.
I'm sorry, perhaps I went a bit overboard there, but thanks, Joe. I think you really touched on all the main points that I was hoping you would, so thank you for that. So moving on now to Thelma. Thelma, I really welcomed your overview of the gaps that you've seen, both from the IPCC report, at least working group 1 aspects of it, but also, I guess, from your own kind of background of working both in Ipcc and in GCOS as Topsy Chair. So I kind of wanted to bring that back as well to this discussion on the biosphere. I know that you have background yourself in this area. So if in GEO we really wanted to step up to this, both the gaps, but also addressing the demands that and the policy kind of evidence that's being put on biosphere aspects at the moment, where would you suggest that GEO as a community should really be putting its efforts? Thank you.
Thank you very much, Mark. And if you allow me also to sort of contextualize a little bit, because we are focusing a lot on the working groups of the Ipcc, like the report that just came out from Working Group 1. But we cannot really forget that for the stock take, the part of the Ipcc, the Task Force on National Greenhouse Gas Inventories, is absolutely key, because many of the indices that have been proposed by the countries relate to reducing their net emissions by a certain percentage relative to their national inventories of a date, normally 2005. That is the case, for instance, for Brazil, but many other countries that say, well, I'm going to reduce 37%, and as in the case of Brazil, relative to my emissions in 2005. So when we come to that, obviously, I think the Federica touched on very relevant points on that, because we need greenhouse gas inventories that are consistent on time, that are accurate, that are transparent. And I want to come to the consistent part of it. So two aspects that I'm going to provide here. One is on the data, activity data, like, for instance, the area that has been deforested, the area under conversion from forest to something else, like agriculture. That is very relevant. Identifying that that is where the satellites can provide a huge amount of information, good information. But let's take a point, and I hope Federica doesn't kill me for that, because I'm jumping into her presentation as well. But when she said that we are providing now that the coalition with GEO and INPE are now creating the land use change maps for a pilot project for Mozambique. She mentioned the spatial resolution of 30 meters. And why did she do that? Because if you are having such a long time series from 1990 until 2019, you cannot use, like, for instance, Sentinel data, which is recent, to reconstruct, back in space, in time. So that's interesting. But then when you come to that, you're talking about Landsat 5, you're talking about Landsat 7, Landsat 8, all of which need to be adapted to be consistent, right? And that sometimes is where we find that information is lacking in the country to do that adaptation and have meaningful information coming from different satellite data. So I think that is an important point on how can countries make the best use possible of satellite data, which for activity data, as I mentioned, is really good. Then you come to the emission factors that might be related to the questions you're making. I raised one of the points, which was in terms of now for the greenhouse gas inventories, they need also to have emission factors or parameters like biomass, right? So above ground biomass is one of them, which for tropical countries, as I already indicated, is still what we have in terms of radar data is not sufficient as yet because they saturated at a certain level for assessing or estimating the biomass for tropical countries. So I hope that we will be able to overcome this in the near future. But the most and fire. I mean, I identified that also in my presentation, but that is really, really relevant. And why? Not only is spatial information, but temporal information, because sometimes the scars of these fires, they disappear, in particular in tropical countries when you have a rain, it goes. So you cannot identify if that is a regrowth, if that's a fire. So there are issues that are still important for us to identify. From the point of view of inventories, it is easier because you are talking about the changes in issues that you see some progress going on. Not as much on soil moisture as we do for instance, the working groups, but talking more about soil carbon changes, which is very difficult to assess. Yeah. Very difficult to assess. So I think that we are progressing, but countries lack the capacity to use the Earth observation data as they could be better explored. Okay. So I hope this helps a little bit, Mark.
Thank you very much, Thelma. So moving quickly on, and we really need to try and provide, if you can just provide very quick answers. Federica, I really appreciated as well this point that you made on, yes, the satellites, of course, are very important, and satellite data, but we shouldn't forget, of course, the in situ contributions, not only to kind of quality control the satellite products, but also to provide that kind of ancillary information that we need to work together with the satellite products. So can you perhaps, as a kind of a new participating organization in GEO, can you perhaps give a few indications of how you would see a coordination body like GEO providing kind of supporting this interface between communities collecting the ground data and the satellite observations? Thanks. Federica, we can't hear you. I don't know if your mic is off.
Yeah, sorry. Thank you, Mark. Thank you. And I think very briefly, the pilot that we're doing with GEO, INPE, and Mozambique at the moment is telling us, we're learning a lot. We're learning pros and cons that we'll be able, in the future to hopefully to replicate. And of course, the more we do, the better we will be. Two elements. I think GEO is very important, providing not only the capacity that it's doing with the satellite, but also the networking that you guys provide with partnership. And I think cooperating together is going to be very important to help the countries. And, even today in this panel, I met, new institutions that they see they're operating in certain elements that I think, could be, able to partner. So GEO is really strategic on that in creating this network of partnership that can be useful for rainforest countries. I guess we are running out of time. I stop here. Thank you, Mark.
That's fine. Thank you very much, Federica. And Barbara, if I can finish with you, I think, and I'm thinking that you will actually appreciate this from your past roles, not only in GEO, but at the WMO as well, and now your current emphasis in the council. And that is, we're really thinking in the public sector efforts on this support to the global stocktake, we're really thinking about this in a system approach. So quite similar to the systems that were implemented in the 1970s and 80s for numerical weather forecasting. So really bringing the observations to bear with the modeling capability, with the in situ capability, and really work in kind of integrated systems that can be distributed, but where everyone's kind of bringing all this capacity together. From that perspective, how would you see the private sector contributions really in the context of this? And by the way, are the private sector also thinking along those lines, or is it more really making the observations and then really finding a customer who can make use of those observations? Thanks.
Yeah, good question, Mark. And actually, I would say probably the latter in terms of the thinking that's going on right now, which is observations and or services, and then finding a customer for it. But I want to be clear, WGIC, the World Geospatial Industry Council, it's a not-for-profit organization, but it's open to any private sector entity that's working in Earth observations or geospatial. So it could go all the way from observations, services, hardware, software, camera manufacturers. So while the field's narrow, it's quite diverse. The members are quite diverse, and can certainly move in that direction. And I guess I want to kind of set the context a little bit. CIAS was designed and stood up in 1984, GEO in 2005. Now we come to the table in 2018 with WGIC. And I think what I'm so personally excited about this partnership with GEO and Climate Trace is it's the first time a systematic analysis has been done of those observations. Okay, fine, it's just GHG monitoring from space, but it could be broader. And so I guess what I'd like to say is these things take time, and yet we've got to continue to find mechanisms that encourage the partnership between the public sector and the private sector. And honestly, that's why we, WGIC, sought out GEO, because it's an entire Earth system. There are other UN organizations that just look at atmosphere or oceans or terrestrial, but we don't have the resources to follow each of those domains separately. We gotta look at an integrated Earth system, okay? And there needs to be a voice, or otherwise each country is just gonna be working one-off, either with their own space agency or with their own private sector company. And you need a more systematic approach if you're gonna look at this global change. Thanks.
Thanks. So thank you to those first four answers. So now I'd like to move to Dave, Andrew, and Manfredi for very quick questions on kind of addressing the second question. And I'll start with Dave. Dave, I've been thinking of your last slide where you kind of left off showing about how we then transition kind of beyond the first global stocktake. What do you really see as kind of the key efforts that the Earth observation community needs to make cumulatively over the next, so once we've started to build this relationship with the users, with the pilots, to transition really into an operational system? So where does our emphasis need to be?
So just to be very brief, first of all, what you've seen and what we're putting on the table for this COP is an effort conducted by a bunch of science organizations using available capabilities to put together products as an example. Well, we need to produce a much more operational system going forward into the future that is a little bit more structured, is dependent on a series of requirements that come out of this effort. The main objective of this was actually to develop that set of requirements in more detail. We need to get those requirements in place. We need also to encourage space agencies to put, what we're talking about so far is using available scientific systems that happen to be available. We need to have much more operational systems such as CO2M, which is targeted for our 2025 deployment. We need to look at an operational system like that, and the data